All right, today we're pulling back the curtain on a technology that is quite literally all around us, but you can't even see it. It's a process that's giving ordinary materials some pretty extraordinary powers. So let's dive into this invisible revolution.
I mean, just think about it. What if your windows could just shrug off fog and dirt all by themselves? Or what if your phone screen was basically unscratchable? Sounds a little like science fiction, right? Well, it's actually a reality that's being built at the nanoscale, and it's all thanks to a process called Sol-Gel.
So what in the world is Sol-Gel? Honestly, the name kind of gives the whole game away. You start with a sol, which is just a fancy word for a liquid solution that's packed with these tiny suspended nanoparticles. Then, with a bit of clever chemistry, that liquid transforms into a gel, this interconnected solid network that forms a microscopic glass-like film on whatever you put it on. It's like building a perfectly engineered coating, literally one molecule at a time.
To really wrap your head around it, let's stop thinking about it as complicated chemistry and start thinking of it like a recipe. How do you take a liquid and turn it into this amazing, high-performance solid film? It really boils down to 4 key steps.
You can almost think of it like making some kind of high-tech jello. Seriously. First up is hydrolysis. You add water to your main ingredients to get them ready to mix and mingle. Then comes condensation. Those ingredients start linking together, forming these tiny particles floating around in the liquid sol. That's your mix. Now, the magic moment is gelation. This is when all those little particles join hands and link up to form a solid, connected network. Your gel has officially set. And finally, drying. You carefully get rid of all the extra liquid, and that gel network shrinks down into this dense, hard, and perfectly smooth coating.
So why go through all this trouble? Well, the perks are huge. For one, this whole process is surprisingly simple and affordable, which is a massive win for manufacturing. It also gives scientists an incredible amount of control, letting them tweak the coating for very specific jobs, like making it extra hard or perfectly clear. And you can do this on massive surfaces, like a whole sheet of architectural glass. And maybe best of all, it's often a greener option, using less energy and fewer harsh chemicals than a lot of older methods.
Okay, so now we know how it's made, but let's get to the really fun part. What can these invisible coatings actually do? Because we are talking about giving everyday surfaces some pretty incredible superpowers.
And look, this isn't magic, it's pure chemistry. But let's be honest, the results feel pretty darn magical. So what can you do with this chemical toolkit? Well, you know that anti-glare coating on your glasses that helps you see without annoying reflections? Yep, that's Sol-Gel. Ever seen those cool self-cleaning windows? They use a Sol-Gel coating to break down dirt with just a little help from the sun. It's also the invisible armor that protects metal from scratches, and it can even create antimicrobial surfaces on things like medical implants to help keep patients safe. The applications are everywhere, just hiding in plain sight.
But the innovation doesn't just stop there. Nope. The next big frontier is all about creating hybrid materials, combining the Sol-Gel process with other things to create coatings that are even more advanced. So, let's see what happens when you start to mix and match.
One of the most exciting new developments is something with a bit of a mouthful of a name, an Ormesol. But the idea behind it is so simple and just brilliant. You take the inorganic part from the Sol-Gel process, that silicate network, which gives you the hardness and durability of glass, and then you weave in an organic polymer, which gives you the flexibility of plastic. You literally get the best of both worlds, all packed into a single super-powered coating.
Sol-Gel also turns out to be an amazing team player. In some of these really advanced hybrid systems, you might start by applying a Sol-Gel coating first. Because it creates such a pure, smooth surface and sticks so well, it acts as the absolute perfect primer, just getting the material ready for whatever's coming next. And then, right on top of that perfect Sol-Gel base, you can add another layer using a different technique, something like physical vapor deposition, or PVD. You can think of PVD as spray painting with individual atoms to build an ultra-thin, super durable topcoat. This PVD layer can add new properties, like a super high gloss finish or extreme resistance to corrosion. The two layers work together to create a final product that's way better than what either one could do on its own.
Of course, no technology is perfect, right? There are definitely still some hurdles to clear. That drying process is really delicate. If you go too fast, you can end up with tiny cracks. It can also be a bit of a slow process, and some formulas just aren't as mechanically tough as other traditional coatings. But the good news is, researchers are on it, working to solve these challenges every single day.
And all that work is leading to a really exciting future. The path forward is looking at things like smart coatings that can actually heal themselves when they get scratched. We're seeing it integrated with 3D printing to create these incredibly complex, multifunctional surfaces. And there's a huge push for sustainability, using materials derived from biological sources. The goal is simple: make these invisible coatings smarter, stronger, and greener.
So, from windows that clean themselves to metals that can heal a scratch, Sol-Gel technology is fundamentally changing our relationship with the world around us. It really makes you wonder, with a tool this powerful and this precise, what kind of intelligent surface are we going to design next?